Hello, this is Danica,
And Jordan.
and we are going to show you how we did problem 5 for section 1 for our Engineering 460 Monte Carlo class. So the problem statement is that you have a bunch of beetles on a table and they're intoxicated, so they're going to take random paths that are going to stumble across the table until they fall off. So our time is being recorded as the number of steps any beetle would take on his random path, and then a step has a random x and y length. So you can kind of see in the image here, we're using like an x and y graph, and then once the beetle has reached the edge of the table, the trial ends because they have fallen off the table. So talking about the step size of that beetle and its path, the change in x is going to be your z, which is just a randomly generated number, your sigma, which is the estimated width of the beetle step, and then the amount of time it takes for each step. Similarly with the change in y, the only difference here is that the sigma is going to be like the length of the step rather than the width of the step that's estimated. And then the time to take one step we're going to say is 0.01. Sigma for both x and y, in this case we're going to use 1, and we're going to simulate that 200 times with the goal of creating a histogram plot so that we can kind of figure out what these paths might look like.
So from that problem statement, here is our code, our MATLAB code that we use. So it's for I 1 to 200, simulated 200 times. You start at the center of the table, x equals 0, y equals 0, establish your step size, and establish your time as 0. Now, we set up a while loop while the beetle is on the table, randomly generate the z variable, and then you do the current x plus the previous x is equal to the previous x plus the step taken, that's the distance it took, and same for the y. And then you're going to basically relate that to the circle, and you're going to figure out if it is inside that circle or outside, and once it gets outside of that circle, it's at times n, and then we record t and figure out the histogram. Now here's our actual MATLAB code, and here's our result showing a histogram that has a logarithmic distribution that has a seems like it has a mean around 2. So yeah, there's our problem.
Alright, thanks for watching, guys.